Good afternoon. Welcome again with Professor C. We're going to be working on linear systems and two variables, this time by the process of elimination. Our first example here is going to be this system 3x plus 7y minus 1, 2x plus y equals to 3. Now remember, the goal of elimination is to literally, what it says, eliminate one of the variables through a bit of manipulation and to be left with the other one. This problem particularly could have been done by substitution. I notice my double colored y here could have been isolated by bringing the 2x over, and that would have been pretty easy by substitution. But we're going to try this one a little bit by elimination. I'm going to number my equations again so I don't get lost. 1, equation 2. And I'm going to look at it carefully and see, the easiest thing for me to eliminate would be perhaps if I took negative 7 and multiplied it by this y here, I would have a positive 7 and a negative 7. That would give me 0y, and I'd be able to eliminate. But I can't just do that for one part of this equation 2. If I'm going to change this by multiplying it by negative 7, I'm going to have to multiply the 2 by negative 7 as well, and the 3 by negative 7. So I'm going to keep track when I'm doing that. I'm going to rewrite my equation 1 here so I don't make any errors. And I'm going to go ahead and write equation 2, 7 times equation 2, which will be negative 14x, negative 7y, and then negative 21. Notice, just draw a nice line and add, and you add x's, y's, and units, just like you were adding, for example, numbers like 116 through 231. You would be adding hundreds, tens, units. In the same way here, I'm adding units, y's, and x's, just keep that in mind. Okay, so here I have 3x minus 14x. That's negative 11x, so that's nice. There's no y, so I'm just going to leave that out. I have the equals, and over here I have negative 22. So I see I've reduced this down to 11x equals negative 22. And I can continue that by simply dividing both sides by negative 11. And that would give me x is equal to positive 2. So that worked pretty fast, and it was pretty straightforward. I've got a value for x, and I'm going to look back at one of my equations, particularly maybe equation 2. So I'm going to take this value. I'm actually going to put it in equation 2. I'll rewrite equation 2 out here for me. 2x plus 7y, 2x plus y equals to 3. And now here I'm going to take the 2 that I say x is equal to, so I'll replace that here. 2 times 2 plus y equals to 3. That means 4 plus y equals to 3. Let's subtract 4 from both sides. Y is equal to negative 1. So I have a value for y, I have a value for x, so I could put that together. X comma y is equal to the 2 for the x and the minus 1 for y. And I got that, by the way, just recently by doing it and solving it in equation 2. So I'm going to go back and look up here. This is my equation 1. So I'm going to rewrite equation 1 out. Here, 3x plus 7y equals negative 1. And I'm going to check this value. I'm going to take the 2 and put it in for x. And I'm going to take the negative 1 and put it in for the y value, what I'm claiming. And let's check to make sure that works. 7 times minus 1. 3 times 2, that's 6. Minus 7, that is indeed equal to negative 1. So I see that this satisfies equation number 1, and we saw it satisfies equation number 2 because that's what we had it. So I can go back to my claim. This is my solution. I draw a nice big box around it because I'm very confident that that's the answer.